In this video, we're going to be looking at solving absolute value equations. Well, what do we know? We know that the absolute value of some number is always greater than or equal to 0. Right? So this is always true. So if we have absolute value of x equal to some negative number, then this is false. And there's no solution. And when we say that there's no solution, we could represent that by the empty set. And this is the symbol to represent the empty set. Okay, let's go back to, now our definition will say if we have some number equal to a, where a is greater than or equal to 0, then x is equal to that number a, or x is equal to minus a. Now, don't be confused. Even though I have a negative sign here, I'm referring to the value of the x. That means inside here, inside there could be negative or positive. Not out here, right? Not on the outside here. So when I have x equal to a or x equal to minus a, I'm referring to the value that's inside the absolute value. Okay, so let's look at an example. So for example, absolute value of 5w, that's a 5, 5w minus 1. 5w minus 1 equal to 4. So I can say 5w minus 1 is equal to 4, or 5w minus 1 is equal to minus 4. So on the left hand side, adding 1 to both sides, I get 5w equal to 5. And then divide both sides by 5, I get w equal to 1. Over here on the right hand side, I could add 1 to both sides. I'll get 5w equal to negative 3. Divide both sides by 5. So w is equal to minus 3/5. And so this is our solution. We could write it as a solution set. And if we write it as a solution set, we write as a solution set this way. So we put the two answers inside the curly brackets and divide and separate the two solutions by a comma. Okay, when we do this, we should check our answer. So let's do a quick check with both of these solutions. So we have absolute value of 5 parenthesis minus 3/5 minus 1, is that equal to 4? So the 5s would cancel out, leaving minus 3 minus 1. Is that equal to 4? Well, we'll have the absolute value of minus 4. Is that equal to 4? Well, absolute value of 4 is 4, and that is equal to 4. So that works. Let's check the other one. So we have absolute value of 5 times 1 minus 1. Is that equal to 4? So we have absolute value of 5 minus 1. So absolute value of 4. absolute value of 4 is equal to 4. So this checks off as well. So whenever we have absolute value equations, we should check our answers to make sure that they work out properly. Okay, let's look at another example. So in this example, we have absolute value of 4x minus 2 plus 8 is equal to 22. So when we have the absolute value here, we need to isolate this absolute value. So I'm going to get rid of the 8. I'll subtract 8 from both sides. And so that leaves the absolute value by itself. So after I've isolated the absolute value by itself on the left-hand side of the equation, then now I could separate it out with the OR statement. So now I could write 4x minus 2 equal to 14, or 4x minus 2 equal to minus 14. So adding 2 to both sides, I get 4x equal to 16. So x is equal to 4. Over here, add 2 to both sides, I will get minus 12. So x is equal to negative 3. And so this is our solutions. X is equal to 4, or x is equal to minus 3. So I could write that in my solution set, minus 3 comma 4. And of course, we can do a quick check. So absolute value of 4 times negative 3 minus 2 plus 8, is that equal to 22? So there's a check I'm doing here. So we have 4 times negative 3, that's negative 12 minus 2 plus 8, is that equal to 22? So we have the absolute value minus 14 plus 8. So this gives us 14 plus 8. And 14 plus 8 is 22. So this checks off. And I'll leave the next one for you to check. Okay. Our next example is absolute value of 9x minus 2 equal to 11x plus 10. And here, when we have an absolute value equal to an absolute value, then we treat it as normal in the sense that on one side, we'll keep everything positive. So we say 9x minus 2 equal to 11x plus 10, or 9x minus 2 equal to minus 11x plus 10. So we only negate one of the sides. Okay, you'll only negate one of the sides. So so here I can add 2 to both sides. I get 9x equal to 11x plus 12, and subtracting 11x from both sides. Subtracting 11x from both sides give us minus 2x equal to 12. Then divide both sides by same number, same value that's in front of the x. So we have x equal to minus 6. Or over here we have 9x minus 2 equal to, well, the negative sign is going to change these to the opposite side. So we're going to get minus 11x minus 10. And now adding 2 to both sides gives us 9x equal minus 11x minus 8. So now here, I'm going to add 11x to both sides. So adding 11x to both sides give me 20x equal to negative 8. And now divide both sides by 20. And this gives me x equal to, well, I can simplify. So I'm dividing the top by 4 and the bottom by 4. So this gives me negative 2 over 5. So I have minus x minus 2/5. Okay, and then we can do checks on this. So I'll do a check with a fraction, and then you could do a check with the minus x, but you'll see that they both hold true. So let's do the check with the fraction here. So we have 9 times minus 2/5 minus 2, is that equal to absolute value of 11 times negative 2/5 plus 10. So we'll have negative 18 over 5 minus 2 equal to minus 22 over 5 plus 10. So this is like 2 over 1. So this becomes minus 18 over 5. Well, the LCD is 5, so this would be 10 over 5. Is that equal to absolute value minus 22 over 5? Again, the common denominator would be 5, but then this is 50. So now if I add, well, they both have the same sign here, so if I combine those together, I get minus 28 over 5. Is that equal to, well, this would be plus 28 over 5. So we know the absolute value was a positive value, so that's 28 over 5. And on the right-hand side, it'd be 28 over 5. So it checks off. Okay, and the other one works as well. Okay, so so the other one works as well. So I'll leave it up to you to practice that. Okay, that's it for this video, and thank you for watching this video.